recording. So today is Wednesday, May 13th, and we will be going over two problems from the cumulative assignment part B. And these will be problems 3 and 4, and I hope to have them posted later today. If not, they will be definitely posted Thursday. Anyway, so here we go. And this is like the very last real FRQ lesson that we'll have. Obviously, I'll be available online to answer questions. So this is the problem that's actually very, very similar or almost exactly the same as what you all had on one of your tests. And a drug company currently sells a prescription pain reliever that has been shown to be effective at lowering arthritis pain. However, since the drug also causes stomach irritation in some patients, the company has created a new formulation that it hopes will reduce that side effect. To see if the new formulation reduces the occurrence of stomach irritation for users of the pain reliever, the company conducted a small preliminary study to compare the new formulation with the current pain reliever. In the preliminary study of 100 subjects with arthritis, 50 were randomly assigned to take the current pain reliever and 50 were randomly assigned to take the new formulation. Yay, we have random assignments. And patient responses at the end of the study are summarized. All right, so we have some stomach irritation and with the current and then with the new out of 50, etc. So do the data from the preliminary study indicate at the 10% level of significance that the new formulation helps reduce the proportion of patients with stomach irritation? So we are concerned about stomach irritation. And we could have run it either way, I guess. You could have run it either had no or had stomach. I ran it as had stomach irritation. And we started off with P1 equals P2, but remember, we must define it. And when I defined it, I said P1 is the true population proportion of patients with stomach irritation using the current medication. And P2 is the proportion with the new medication. And the hope is that the new is less than the current. So we're hoping that P1 has greater stomach irritation than P2. Really, we're just hoping P2 is going to be less. So, conditions. 2 independent random assigned samples of 50, they were given. Please make sure you use the word independent and random. That's really important. Then we need to check the N is less than 10%, or normally you would. Because this is an experiment, treatments were assigned, it is not necessary to check the N is less than 10%. If you do check it because you're not sure when you're supposed to or not, it isn't an issue. But it's not required on an experiment. But if you do check it, they're not going to count it wrong. So it's okay to include it if you choose to. All right. So we had 21 with the new one, with the current, who had stomach irritation. And we had 29 who didn't. Both those numbers are greater than 10. We have to satisfy both of those conditions. And for the new one, we had 17 who had stomach irritation and 33 who did not. And those had to be satisfied. And they had to be satisfied in order for the samples to be large enough to use a normal approximation. Because all 4 are met, and only because all 4 are met, we can go ahead and proceed with this test. So 21 out of 50 or 42%, and then 17 out of 50 or 34%. These are the percentages that had stomach irritation. Because we are working with a 2-sample proportion, we do have to pool. Because the assumption up here, and the reason we do this, is the assumption up here is that the proportions are equal. So by combining the 2 samples, we think that we would get a better estimate. So that's essentially what we're doing. 20 over 50 plus 17 over 50. And when we end up doing that, we end up getting a P pooled or a P combined of 38%. All right, so I wrote down my formula. You always should include the formula. This is not showing up very well. I apologize for that. It should have made it bigger. And then I plugged in proportion 1 minus proportion 2. And then it was PC or P pooled, 1 minus P pooled over the sample size of the current pain reliever. This should have said 0.34. That's a typo. That should say 0.34 times 0.62 over 50. So let's go ahead and plug this into the calculator. Since this is two proportions, stats test, two proportion z-test, which happens to be number 6. And we had 21 who had stomach irritation out of 50 for the current, 17 out of 50 for the new, and our alternative hypothesis had a greater than. So we need to make sure that our greater than is highlighted, which it is. And we calculate, we get a z-score of 0.8241 and a probability of 0.2049. That is a fairly large p-value. And with a p-value like that, when we compare it to the alpha of 10%, which they gave us, we're going to fail to reject the null. So then we always have to state our conclusion. This is not, we don't get to make this choice. We have to always do this. Our p-value is 0.2049. We fail to reject the null. There's not sufficient evidence at alpha equal 0.10 to suggest that the true population proportions with stomach irritation using the current drug is greater than those using the new drug. I always recommend, it's not always required, that you say, hey, what was the question they were asking? Whether it, in this case, the question was, did it decrease? So I recommend put it into everyday language. And when we compare it to the current drug, we cannot say that the new drug decreases the proportion of people developing stomach irritation. So in other words, we are not sure, at least at an alpha of 10%, that this is being effective. So I'm going to pause the recording. Okay, it was pointed out to me that the small print was way too small to read, so here we go. This is the P of the current minus the P of the new. This is 0.38 for the P of the combined. 1 minus that is 0.62 over the current sample size. P combined, 1 minus P combined, over the sample size of the new. Turns out that they were the same in this case, but the sample sizes did not need to be the same. The numerators, however, for this type of problem have to be the same. So this part right here needed to be the same, but this part right here, the sample sizes, they could have differed. Okay, moving on. Based on your conclusions in part A, which type of error, type 1 or type 2, is possible, then it says describe the consequences of each. So we have to talk about each error, even though we could have only committed one. Because we failed to reject, the only type of error that could be committed is a type 2. Doesn't mean we did, but it's the only type that could. If we committed a type 2 error, that means we failed to reject a false null. In this case, it would mean that the new arthritis drug did reduce the amount of stomach irritation, but we believe that there was no difference. All right? So in this case, it would be believing that the new drug, the new drug had no effect over the current drug, when in fact the new drug actually worked. The consequence is the company might not bring the new drug to market, which would mean that patients would not have the opportunity to use a drug that has less stomach irritation. There are several consequences you could have listed. That's the one that first came to my mind. But you could have come up with something else that made sense, but you need to list a consequence. The next one, the type 1 error. They told me that I had to give a consequence for each. And a consequence for the type 1 error is we would be rejecting a true null. The consequence, and basically a true null says that there was no difference. The consequence would be that the company would bring a drug to market advertising it helps with stomach irritation when it didn't. All right? So the consequence is that they'd be bringing an effective drug and false advertising on that. And I'm going to pause right here because that's a fair amount of writing for you all to get. Okay, after the preliminary study, one of the researchers of the company suggested that the procedure described above would have more statistical power if the sample size was increased. And we know that that's true. If you increase sample size, power increases. And recommended that a simulation study be conducted to investigate more completely. For the purpose of the simulation, the researcher assumed that 40% of the patients on the current pain reliever will have stomach irritation and that only 30% of the patients on the new formulation will have stomach irritation. Further, the total sample will now be 200, with 100 subjects randomly assigned to each treatment. 100 trials of the simulation were conducted, and a p-value was calculated for each trial. Based on the testing procedure, significance levels, and hypothesis tests in use part A, a histogram of the p-values is given below. So in other words, they use this exact same test that we ran on the previous page, but they did this using simulations and go, hey, if in fact the proportion is 30% who with the new medication and 40% with the current medication, how often is that going to have a p, what's the p-value going to be for that? So they recorded all the different p-values, and you can see that it went all the way up to about 90%, and it went all the way down to very small. So use the information in the histogram to estimate the power of the test if the test is performed at the 0.10 level of significance. But please remember, this is the p-values, and this is a frequency, and they ran this thing however many times they did it, and you sit there and you go, and these are percentage, these are actually supposed to be percentages here, but we sit there and go, okay, 45 times they had a p-value of less than 5%, and then an additional 14 or 15 times they had a p-value between 5% and 10%. These right here are p-values that are less than alpha. Those p-values that I circled are all less than alpha of 0.10. Well, how many times did they happen? Well, that happened for, we had 0.45 plus, I'm going to call it 0.15. All right, so this p-value happens 60% of the time. And the reason I know it's less than alpha is because I look here, and these right here, anything less than 0.1, would be acceptable. And I know some people are going, hey, does that include 0.1? And I'm going to remind you just a little bit of Algebra 2, the way this sets up. This sets up that the first p-value is from 0 to 0.5, not inclusive, or not 0.5, 0.05. And then this next one is 0.5 to 0.10, not inclusive. So basically, it should have been, these are set like that on the denominator, or on the x-axis. So consequently, all of these, this direction, are p-values that were less than alpha, and it happened to happen 0.45 for this time and 0.15 for a total for 60% of the time. So the power of the test is correctly rejecting a false null that the two medications have an equal amount of stomach irritation. So that's the false null. And we know it's false because they said the actual value of those taking the new drug is 30% versus 40% for the current medication. So there definitely is a difference. There's a difference between the new drug and the current drug. So we should be rejecting the null. Thus, we need to know the probability of rejecting the null. And we will reject the null if our p-value is less than 0.1. And as I said here, our simulation estimates the power of the test is 0.60. And you need to show where that came from, 0.45 plus 0.15. Now, that's a little bit of a challenging question. I'm going to pause this for just a moment. All right, part D, calculate the probability of a type 2 error. Well, if you understand part C, then part D is easy. If you can't do part C, then part D is almost impossible. Calculating a type 2 error, that means my p-value had to be greater than alpha. So if my p-value was greater than alpha, I failed to reject. Well, that happened. All of that area right up there, my p-value was greater than the alpha. So the part in orange, I would have failed to reject. So I could try to add up all of these, but that's a lot of work. And I know that power equals 1 minus type 2. So in this case, since we know that power was 0.6, 1 minus 0.6 is 0.4, so the probability of committing a type 2 error would have been 0.4. And all I did was say, hey, we said up here that these right here, these probabilities right here that I circled added up to 60%, and that's when I would actually reject. So that means what's left would be this, so I could subtract them. Actually, on the test, when I gave this particular problem, I actually had a student who, when they calculated power, they added all of these up and they subtracted from 1. And that's completely correct. So they've actually calculated the type 2 error, and then they subtracted to get power. That's kind of a long way to answer it, but that is absolutely correct.